Brendan. This is going to be a video to help you with the organic chemistry and how to understand hydride shifts and methyl shifts. Hydride shifts and methyl shifts can be an extremely confusing topic in organic chemistry, so let's get into it and try to give you kind of a clear, cut and dry explanation. So in order for a hydride or a methyl shift to occur, one thing that's needed is you need to have some kind of carbocation intermediate. A hydride shift or methyl shift will not occur unless this happens. Now, once you recognize that there's a carbocation intermediate, there's basically two things that you have to look for. One, is your secondary carbocation next to a tertiary center? Or is your secondary carbocation next to a quaternary center? If either of these are true, it means you could potentially have a hydride or methyl shift. So let's just give you a quick drawing as to what that looks like. This would be an example of a carbocation that is secondary next to a tertiary center. What we can see is this carbon is secondary because it's attached directly to two other carbons, and then this carbon over here is tertiary because it's directly attached to three different atoms. Now, a secondary carbocation next to a quaternary center looks like this. So again, we see a positive charge on the secondary carbon, and that is next to a carbon that is directly attached to four different hydrogens. Now, when we have a secondary carbocation next to a tertiary center, we're going to see hydride shifts. When we see a secondary carbocation next to a quaternary center, that's where we're most likely going to see methyl shifts. So what exactly happens here? Well, hydride shift is because there is a hydrogen right here, and that hydrogen can jump over there. The reason that happens is after that hydrogen has moved positions, its electrons have vacated this carbon, therefore leaving a positive charge on the tertiary center. Now, what we know about carbocation stability is the more highly substituted that carbocation is, the more stable it is. And as with everything in organic chemistry, it wants to go to the most stable form. So because this hydride shift can occur, moving from a secondary carbocation to a tertiary carbocation, it's energetically favorable, and so it'll take place in your mechanism. By all the exact same principles, a methyl shift can occur when secondary is next to quaternary. And when that happens, we again form a tertiary carbocation because that methyl group has left to go over to the other side. With it, it has brought its electrons, leaving an empty orbital, which therefore results in a positive charge on that carbon. And that's really it. That's what happens in order to produce a methyl shift and a hydride shift. What I'm going to do is I'm just going to show you how it might look in a reaction, a mechanism that you might see. A lot of times on an organic chemistry exam, they may give you a little bit of a hint, some kind of give me that it's taking place. This here. Actually, let's do a different example. Let's do this. And they may ask you to propose a mechanism, but they may tell you what the final product is. So I'm going to go ahead and tell you that. The final product is one which occurs after a shift has taken place. And you end up with your bromine here on this position. So you know something happened because that bromine did not add on a carbon that was on either side of the double bond. Rather, it added somewhere else. Some kind of shift must have taken place, and that's your hint for that. So let's try to draw the mechanism and see if we can pull that shift out. So as we know, with addition of a hydrogen halide. The alkene, the double bond, is going to grab the H. When it does that, it wants to open up to the more substituted carbon. In this case, they're both secondary, but because this carbon is a little bit closer to these extra electron donating groups, it's going to open, kind of hinge over off to the left, and you're going to be left with a positive charge on that position, and a Br minus. Now, it's at this point that the methyl shift, or the hydride shift, I'm sorry, can occur because you have a secondary carbocation next to a tertiary center. So this is going to jump over there. So I'll draw this going down here. When that happens, actually, I'll draw it off over here to the right. So when that happens, we now have a positive charge right here because our H has moved. Again, this happens because it's energetically favorable. And the Br minus that was there can now come in and attack, leading us to our final product. And that's it. That's the basics of methyl shifts and hydride shifts. They might seem way more intimidating than they actually are. Just watch out anytime you form a secondary carbocation, whether it's in an SM1 mechanism or an E1 mechanism or an addition mechanism, just anywhere where a carbocation can form, you do have the potential for one of these shifts to happen. Thanks for watching. I really hope you found this video helpful. Feel free to like and subscribe to my channel.